Hi class, I'm going to be discussing the exponential probability distribution in this video. And this is on page 269 of your text, so 269. So I've said it before, but continuous distributions are commonly used to measure the time between arrivals or failures in a business process. And so I don't know if I told you guys this before, but I used to work for Ford Motor Company, and one of my first jobs there was to work in that. I worked in assembly. So I worked where they assembled the Mustangs. And one of the things that we did was we wanted to be able to curtail downtime for machining failures or process failures. And so we use probability to try to figure out more accurately when we need to shut a line down to retool certain stations. And so when we talk about the exponential distribution, this is a prime example of a distribution you would use to try to calculate something like this. So the values tend to, the low values tend to dominate so if we have low values here, right? And then high values over here, right? So the high values are less occurring and the low values seem to dominate. And this also holds true for if you were a call center, right? So if you were a call center, you would think that the shorter calls would tend to dominate and that the longer calls will be less occurring, right? So with this, let's talk about the exponential probability density function, right? So the probability density function is here. The probability of x is equal to lambda to the lambda times e to the negative lambda x, right? With e being 2.71828. And we talked about this a little bit with the Poisson distribution in the previous chapter. So if you want to think about Poisson and exponential distributions kind of being like a yin and a yang. So with Poisson distribution, you are actually counting the number of occurrences that are going to happen. And then with the exponential distribution, you're counting the time between occurrences, right? So you're measuring the time between occurrences versus counting the number of occurrences, right? So in this particular type of distribution, lambda is going to be equal to the number of customers per hour, right? And or I said per hour right now because I'm talking about the example that's in the book, but lambda is the mean number of occurrences and x is the number of interest, right? So you're given a situation in the book, and I think the book is telling you that you have, if lambda is equal to 12 customers per hour, right? So it's saying if you have 12 customers per hour, right? And then, mu is the average number of customers, and mu is equal to 1 over lambda. So if we have 12 customers per hour, we know that there's 1 hour, right, over the 12 customers. And if we multiply that times 60 minutes per hour, right, then that is going to give us 5 customers per minute. I'm sorry, 5 minutes per customer. All right, so let's talk about using the Poisson distribution, which is the counterpart, right? And finding the actual exponential distribution. So if you follow me over to page 270, right, the Poisson distribution, and there is some criteria that's given to you on page 270, the differences between exponential and normal distribution. But the mean is equal to mu over lambda, and lambda is also equal to 1 over mu. Those two things are interchangeable. We're going to use this formula right here, and I use Excel for this, but the probability that x is less than or equal to a, because this is a continuous probability distribution. So with continuous, we're always going to be finding the area under the curve, right? So if this is continuous probability distribution, we know that the probability that x is less than or equal to a is equal to 1 minus e to the negative a times lambda, right? And so they give us another situation in the book, and they talk about if we want to talk about the Piggly Wiggly grocery store, you guys know, if you can't tell from my accent, I am very much from Atlanta, Georgia, where the Piggly Wiggly is alive and well. And so suppose that the average time between customer arrivals at the deli of the Piggly Wiggly grocery store is 4 minutes. What is the probability that the next customer will arrive at the counter within the next 2 minutes, right? So if we talk about the Piggly Wiggly grocery store, I'm just going to draw another one here, right? And I'm just mimicking what's in your book. And we say that we're looking for the probability the next arrival is going to happen in less than 2 minutes, right? And if we say this is the 2 minutes, we're trying to find this area right here. And we know that it's not quite going to touch, right? So we find this by saying, we know that mu, right? They told us that mu, from taking it from here, is equal to 4 minutes per customer, right? And that we know now that lambda is equal to 1 over mu, and that is one customer per 4 minutes. And that is going to give us 0.25 customers per minute. Right. And so with that 0.25 customers per minute, we now know that the probability, if that's equal to 2, right, given this formula, is equal to 1 minus E, right, to the A, which is going to be 2 times my lambda, right, which is 0.25. And that is going to give me 0.3935. So there is a 39% chance that the next customer will arrive within the next 2 minutes. All right. And if I were to take the difference, I would do the same thing to take the difference between these two. If I want to say the probability the customer is going to arrive between the next, I would say, 1 to 2 minutes, I would find the probability of x less than or equal to 2, right? And I also have to find the probability of x less than or equal to 1, and I find the difference between the two. So when you calculating the exponential distribution, like I said, I don't like to fuss around with these equations, these formulas. So you would find that by using this equation in Excel. And there's, your book gives Excel explanation for everything. I'm kind of old school with Z-score. You can use Excel to calculate Z-score if you'd like to as well. But for this exponential distribution, the Excel formula is EXPON dot DIST. And you plug in X, lambda, and cumulative. And for these problems, and I'm going to write this in red, if I can get red to come up. This is going to be true. So for cumulative distribution, I'm writing it red and all caps. This is always true. All right. So any questions? Not come see me. Email me.